Okay, this is a quick little video just to show you guys pretty much what you need to do to answer the questions for the lab summary for this lab. Alright, I'm not going to go through every single one of these. I'm not going to go through every single one of these questions. Okay, but I'm going to show you enough for the exemplary ones that you should be able to get the rest. Okay? Now, some of you already did this, okay? And that's great. But some people obviously struggled. So here you go. Alright, so what I got here, I have made up two data sets, right? These are fake data, not real, alright? But I got snails from the north and the south. These are their length data. These are the mass data. Okay, how much they weigh. Alright, so results for graphs. Make sure you follow proper scientific graph making rules. That's stipulated on the website. There's a whole bunch of instructions about how to make graphs in Excel that are good scientific graphs. But, alright, let's see here. I'm just going to go ahead and do it for the mass data. We need means and standard deviation for your two populations. So, here's the mass. Here are the two populations, north and south. I am putting this together so I can compare the north and the south. Now, some people do, or I've seen graphs that might look like this. Some people submitted graphs that look like that. That's meaningless. That doesn't tell me anything. When you do a graph like this, right? Think about what information are you trying to convey. This doesn't convey any information at all. Okay. To be literal, yes, there's a little bit of information there, but it's not information that doesn't me any good. First of all, what are these numbers here on the x-axis? They're the individual snails. Well, who cares? What is number 14? Number 14 is meaningless, right? Number 14 is just, is not here. It's not number 14 for any particular reason. It could be number 5, or it could be number 9, right? This order has no meaning whatsoever. And this doesn't tell me anything, right? Why we have this line of snails like this? So that's not going to help us. What are we trying to do? We are trying to compare the mass of the snails in the north and the south. Okay? So, tell you what, I'm doing this all on the fly. So, if it's come on, what are you doing to me? PowerPoint, there we go. Alright, so I'm just doing this all on the fly, this lecture, this video. So it should become, so it's not going to be the most polished thing. Whatever. You'll get it. I'm trying to compare north and the south, which means I'm going to want north versus south. And what am I trying to compare? It tells me right here in the instructions. The means of the mass. So this would be the mass in grams, right? That's what we measured it in. Now, ideally, what you would have is a symbol here for the north and a symbol here for the south. That is the mean value for the north, and that's the mean value for the south. Whenever, as we talked about in class, and as it says on the instructions, whenever you report means, you have to include the standard deviation or some sort of measurement like that. Boom. So that would be, this would be one standard deviation. So that's one standard deviation above, one standard deviation below the mean. So this is what you should do, something that looks like this. Now some people, in fact, most people put in a bar. Most people that did this correctly put in a bar rather than a symbol, right? Not this little symbol thing here, but a bar, which, okay, is fine. It's technically incorrect because bars are really for counts, not measurements, right? So if you were counting the number of snails, run out of space there. But okay, I wouldn't care. I wasn't going to take off points for that. That's not a big deal. Bars are just as fine. So that's what we want. We want something that looks basically like that. So what we first need to do is calculate the means. So I'm just going to do it like this right here. And give myself an extra column. I'm going to put the mean. And calculate the mean as you put an equal sign, average, parentheses, brackets if you're British. And then I'm just going to select, I'm going to select the entire column D, because all the data in D are my north data. And I close the brackets, aka parentheses, and I hit enter. Boom. And then I can just copy that. Copy. Normally I would hit Control C, Control V, and then I paste it. Whoa, that's a big difference. All right. So the mean mass of the north ones, I just made these data up, so they're not realistic, but okay. The mean mass in the north is 62.47 grams. In the south, it's 22.39 grams. But I also need, well, yeah, I can show you here. I also need the standard deviations. So standard deviation is going to be equal to the standard deviation. We want standard deviation S. This is a sample. Trying to get the standard deviation of the sample. We can type this out, or we just click on it, standard deviation.s, have the open brackets, we're going to select the whole thing, hit enter. I'm just going to hit Control C to copy, Control V to paste, boom. Let me make this a little bit bigger. Okay. Alright, so now we have the standard deviation in the north, standard deviation in the south. This is what we plot. That right there, these data, we don't plot this. No one cares ever about all of your raw data. Never. Okay. Never with an asterisk. Maybe someone cares somewhere. But when you are publishing your results, whether it's in a lab report, lab summary, or you're submitting them to a scientific journal, no one wants to see all your raw data. It's just going to be a headache. So you give them the mean and the standard deviation. Okay, so how do we plot this? I'm going to do the north and the south. And I'm going to, rather than spend more time doing the symbol, I'm just going to do the bar graph, because it's faster and it's good enough. Okay, boom. So I selected, show you again, I select north and south, and the mean data, not the standard deviation, but just the mean. And I come here to insert. I'm going to do 2D column. There. All right. Now that's not good enough. That looks like garbage when you think of how scientific figures are supposed to look. Get rid of chart title. Right, chart title does not go there. Let's get rid of these horizontal lines. Those look like garbage. Okay, let's put in y-axis. So we're going to add, I'll come over here, add chart element, axes, we're going to add axes, we're going to add, sorry. I don't use Excel for plotting my scientific figures so much. So I have to figure out some of this again every once in a while. There's actually already an axis there. What we need to do is to change the format of the axis. So format, vertical axis, see how it's selected over here? Format selection. And let me think about how to do this. We want to do that. Alright, so we click on this paint thing, we go to line, we want a solid line. Boom. Now there's a solid line there. Now that looks different from this one. You know, really we should fix this solid line down there. So we select the horizontal axis, format selection, solid line. They should look the same. Okay. But now we got north, south. we have something here. What is this? We don't know what these values are. So we're going to have to add, in this case, we're going to add something. So we go to chart design, add chart element up here in the left corner, axis titles, primary vertical. Click on that and you see it's already added an axis title there. And let's just go ahead and change the axis title. This is mass, and parentheses grams, because it's grams. Okay, and now we don't have to necessarily put site down here. These are the sites. We can put that in the figure title if we want, but you could add that if you really want it. All right, but we also have to add what we need still. We need the error bars. So select our figure, chart design, add chart element, scroll down to error bars. Don't select any of these. We want to do our own calculation. So we do more error bar options. Okay, we want them going in both directions. End style, we want a cap. Okay, you just leave this as default. What do we want? We want a custom value. Let's specify that value. See how it's custom, specify value down here in the right column, right corner. Okay, positive error value. I wanted to select 21.65 for the north, 7.90 for the south, so I select that for both of them. And then for the negative error value, I select them again. So it's going to add the same amount above and below. So we should see that the error bars for the northern population are about almost 3 times as large as the error bars for the southern population, right? Always check your data, make sure it makes sense, and hit OK. Let's get rid of that. Take a look at this. Yeah, that looks about right. Looks about 3 times as large. This average is 62. The mean is 62, which means the error bar should come up to 62 plus 21, should come up to about 83, 84 with whatever. And yeah, that looks about right. Okay, boom. That right there is a figure. That is a perfectly good figure scientifically. All right, so here is the simplest thing. The simplest thing to do is just select your figure here and copy it. So I'm going to right click so you can see. I'm going to right click so you can see what I do and come up here to copy. All right, and then I'm going to come over here to my document. This is where I'm going to have all of my answers. And then I'm going to paste it. But rather than just pasting it regularly, I'm going to paste it as an image or as a picture. See how it has that little picture there on the clipboard? This way, it doesn't get all funky. Right? It's just a picture. It's always going to be a picture. Just like if I pasted a JPEG into the document. Okay? I'll show you what happens if you don't do that. If I just paste it regularly, boom, I paste it regularly. Okay, it looks pretty much the same. And I click on it, and it's actually interacting with the Excel document, which in some cases is fine, but when you change things in Excel, it's going to change things in here, and it can mess up your document. So just paste it as a picture, and then you know it'll always be there. And then if you want to, watch, let me show you. I can click on this, and I can delete that stuff. Or let me see if I can just delete the error bars. I can delete the error bars, which I don't want to do, but you could mistakenly do stuff like that. So put it as an image, and you're good. Okay. A benefit of that is that if you want to then do this with your other data sets, you already have this figure template put together, then you could just do on the average of, actually here, I'll just type it right in here and show you. The average of the lengths from the north and the average of the lengths from the south. So what I did was I just went in here to into the parentheses, which says average, and just changed the data. I haven't changed the standard deviations yet. So I'm changing them from column D to column A. And so what it does is the graph looks exactly the same. Well, I mean, it's the same formatting, same structure, but the data are now updated. So now this is no longer the mass data. I can come in here. I click on my y-axis, which says mass. I'm going to double click on that. I'm going to change it to length. And in length, we're dealing with millimeters. Boom. And now I have a new figure. And I didn't have to go through that whole rigmarole of trying to correct Excel's crappy figure formatting. Alright, and so I can come here, and I can paste it as an image, and now I've got my length figure. Okay, so I have my mass figure hasn't changed, my length figure hasn't changed. But if I were to then come here and try that, so I'm just going to hit Control Z so I go back to having mass. Okay, if I did that, then my figure over here, well, I pasted this as an image, but if I had pasted it as a, not as an image, right, it would be all messed up. Okay, so paste it as an image, and then you're done with it. You can just go on. You don't have to repeat all of your work. Okay, so what do I need? I need, for graphs, make sure you follow proper scientific graph making rules. Alright. For every figure, you need a title. This I'm going to call figure 1. What would be a good title for this? The title is descriptive, so that if someone just sees the title in the figure, they'll have a pretty good idea of what's going on. So I would call this mean mass of snail shells. I'm just calling this off the top of my head. From 2 populations in the Bahamas. One population is a northern population, and one is a southern population. The bars, now you have to tell people what these represent. The bars represent the mean values, and then I can insert symbol plus or minus, let me get rid of that parentheses, plus or minus 1 standard deviation. And that's pretty good. That describes what's going on here very well. And I'm talking about mass. I tell them that the bars represent 2 different populations, and the bars represent the mean plus or minus 1 standard deviation. Perfect. Okay, that would be the answer for number 1. Number 2 would be length data, do the same thing. Number 3 would be width data, do the same thing. All right, number 4 is a correlation. Okay, so to plot a correlation in Excel, you need X data. What's a correlation going to look like? Well, something like this. I don't know if you can see this. I'm going to make these marks bigger. And you have some value on the bottom and some value on the left axis. Correlation between length and mass. So we're going to say that length is probably the thing that contributes mass to mass. The longer a snail is, the more it weighs. It doesn't, I mean, it makes sense that the more it weighs, the longer it's going to be, but we think mass is going to come from length. Okay, and so this would be a correlation. Now, I said you'd have to put data from both populations in the same graph, but enter them as different data sets. So it's clear which population has crabs and which one doesn't. So what this requires is a separate data set with different colors, different symbols. Okay. So I'm just going to copy these and move them over here just to give ourselves some more space. So this snail here that has a length of 18 has a mass of 45. This one 32 has a mass of 79. This one here that's 20 has a mass of 25. All right, so what we need to do, I'll just show you just for the north. So this is length, and this is mass for the north. You'll see why I did this in a second. I have the x data, which is going to be the length, and the y data, which is the mass, right next to each other. I select all of them, and I'm going to hit insert, and I click on this one down here. X, Y scatter. Nothing connecting them. I just want it to be a scatter plot. And you see, this is basically what it looks like. So this is going to be the length data down here. This will be the mass data here on the y-axis. And then each of these represents a single snail. So this particular snail has a length of 25 and a mass of just over 70. If I click on it, if I hover over it, you can see 71.5. This is another snail. These are actually two snails right here. 32 and 79. Okay, but I'm not going to give you individual details because that will just be cluttering. But remember, you need to get two data sets. This is where plotting in Excel becomes a little bit wonky. So here's what I'm going to do. I'm going to put all of the X data in one single column. Okay, all of the X data, which is in this case is length, goes into one single column. So here's the length of the individuals from the north, and then here's the length from the individuals from the south. The Y data will go in two separate columns. So I'm going to copy this mass data for the south and put it here. Here's the length data, but you'll see that what I'm telling Excel is that for 18, there are these two. For a snail that's length 8 of 18, there's a snail from the north whose mass is 45, from the south whose mass is 24.5. That doesn't make sense because this guy is not tied in with this value 18. What I have to do is come down here and put them there so that they align there. So now I'm zoomed out, I have all of the length data in one column. The northern data, the northern Y data are in a second column. The southern Y data are in a second column. And they're divided so that they match up with their particular data. Right? So this snail right here, that's one pair, that's one snail. That right there, that's one snail. Okay? And so I'm going to leave it zoomed out for just a bit. I'm going to select all three columns and their column headings, the titles. I'm going to select all of them like that. I hit insert. I'm going to select the same thing as before, a scatter plot. I'm going to drag that sucker over here so it's out of the way, and I'm going to zoom back in on it. Boom. So that's it. I have now X data here, Y data here. This is length, this is mass, and I have the two populations north and south. Excel sticks this legend here. That doesn't do me any good. I'm going to move it up there. Right? Make sure you put in, I can go ahead and I'll do all the settings. Okay? So let's make this actually look good. Boom, chart title, don't need it. Oh, sorry, I hit the wrong button. Deleting those, so to delete these, I just select it, and then I just hit the delete button. Select, hit delete. Select, and now I've selected the horizontal lines, hit delete. Okay. I need to insert some things. Okay, but before I do that, it's using circles for both. That's a bad idea. Okay? It's using different colors, but using circles for both is a bad idea. So let's change the format of those. Let's go to format. What do we want to format? Select here. Series north. Let's leave north as blue circles. Let's format series south. Okay. Now we want to, so we've selected Series South up here. Series South is just Excel's way of saying the data for South. And we hit Format Selection. Now we want to change the symbols, right? I think this will take us there. So we click on, no, let's do this one. It's the bar one. So let's click on Series Options. Wait, is it? Oh, okay. Stupid Excel. It says Paint Symbol. All right. Paint Symbol. We want to change the marker. Click on the marker. Marker Options. Don't use automatic. Use built-in. Pick a different shape. Something that'll stand out. A triangle is good. That's also, we can leave the color, but let's make the internal color not solid. Okay? So now we have two obviously different symbols. Circles that are blue and filled in, triangles that are orange and are open. All right? So it doesn't matter if someone's looking at this in black and white because they have a photocopy or you print it out that way. It will be clear which one is which. Okay, so then let's see. What do we have to add? We have to add axis titles. So chart design, add chart element, axis titles. We want to add primary horizontal and primary vertical. The primary horizontal is going to be length in millimeters. Primary vertical, just double click on that, and this is going to be mass in grams, and then I'm going to delete the rest of that there. Boom. Now, see how Excel kind of shoved this into the top? Let's click on this and drag it down a little bit. Boom. Make it fill out nice and make it fill out nicely. We don't have a whole lot. There's a little bit of empty space here, but that's not too bad. So we'll just leave that as it is. If you got a lot of white space on one side or another, you should change the axis values. But I'm just going to, for our purposes, that's good. I'm going to select it. I'm going to copy it. I'm going to come over to my Word document. And I'm going to do home, paste it as an image, and boom, there it is. Okay? And I can always make it bigger, smaller, depending on how I want. And then I still have to add a figure title. Each of the figures needs a figure title. I'm going to leave that much up to you. Okay? That should be something you should be able to figure out at this stage. Okay, so that's not what I want. That's what I wanted. All right. Boom, boom, boom. So I'm going to assume that you can do these 4 graphs now. Let's look at some of these questions. I'm not going to go through every question, but I'm going to show you examples for a few key questions. So what were your null and alternative hypotheses? Those are things that you came up with in class, and then you're putting them here. Remember, a null hypothesis is generally when there is no difference. An alternative hypothesis, which can be HA or H1, is going to be everything else. Everything else. So, for example, if your null hypothesis where there is no difference in length between the snails of the northern and southern populations, your alternate hypothesis would have to be not the northern population is bigger, but would have to be there is a difference. Easy peasy. I'm just going to copy this and paste it. There is a difference in length. Okay? That's an example of how that would work. All right, so just looking at the data without running a stats test, would you accept or reject your null hypothesis? So just look at the figure and say, I would accept my null hypothesis, or I would reject my null hypothesis. In this case, I would reject it. I would say that there is, we're looking at mass, but not length, but I would say yes, there is a difference in mass between the snails in the north and the south. I would reject my null, which means I would accept my alternative hypothesis. All right, boom, boom, boom. Report the results of the one t-test that applies to your hypothesis. Report the results properly. Okay, so let's go back here, right? And if we're doing a t-test, let's say I'm do the t-test on mass. Okay. Here's mass. I'm going to do my t-test on that. So remember, a t-test compares the means of two samples. How do I do it? I come to data analysis. Now, a lot of you guys did this much properly, and that's good. Two sample assuming equal variances. So this comes up here. Variable 1 range. I'm just going to select the title at the top. Okay. Variable 2 range. I come here and I'm just going to select everything there. Hypothesize mean difference. You can leave this blank because we're expanding it to be 0. It assumes it's 0. Labels, because I have the labels selected, I have to click labels. Output range, I like to put it right in this figure, right in the sheet. So I click output range. I click there, and then I click on that cell. That's where I want my results to go. And I hit OK. Boom. Here are my results. Now the means gives me the means. Those are the same as the means you can see above. Gives me variance, which is related to standard deviation, but we generally don't report variance. It gives me the sample size, which is 18. Degrees of freedom, which is important for the test. My t statistic, which is the value of my test, and so the bigger the t, the more likely there is to be a difference. And then it gives me my p value, which is my critical value. And this is 2.9 e negative 0.7. What that is 2.9 times 10 to the negative 7th power, right? So really, really, really small. Okay, another way to write that would be 0.029. Okay, and so that's what the value is if I make this smaller, too small. Okay, when Excel can't show you the number because it's so small, there's too many decimal places, it gives you this scientific notation. But that's what it is. Okay, so what is it we have to report? The means we need, but we've already shown the means here. Right, so when I'm looking at this, I can look here and see the means. We need the degrees of freedom. We need the t-value. And we need the two-tail p. All right, so I'm going to report my t-test. I'm going to say there was a statistically significant difference between the means, the mean masses, I'm doing this off the top of my head, of the two populations. And then I'm going to put in parentheses the information. So I did a t-test, colon, and then someone can say, they're reading this, they know exactly, oh, they did a t-test. What was their t-value? So you report the t-value, which was 7.389. 7.389. Generally, 3 decimal places is plenty. Any more, and you're just showing off. Your degrees of freedom, which is 21 degrees of freedom. That tells someone how many data points you had. okay, and our p-value. Now you wouldn't put p is equal to 0.00000, I don't know, 0, 1, 2, 3, 4, 5, 6, 2, 9. You wouldn't put that. Because remember, what's important is the p less than 0.05. That's what's important. This is way, 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 way less than 0.05. So generally what we would do is this. We put p is less than, much less than 0.001. And that's as far as we would go, 3 decimal places. All right, and that tells us that it's very, very small. And whatever, some people think it's obnoxious to have so many of those things, those less than symbols. Okay? Boom. So that's it. I've just reported the results of my statistical test. Now, there is actually a way to improve this. I say there was a statistically significant difference. Why would I just say there's a difference? Why don't I tell you what the difference is? I can tell you what the difference is and not take up any more space. The North is bigger than the South. So I'm going to change this to the mass, or the mean mass of the northern population was significantly larger than that of the southern population. And I'm going to delete all that other stuff. Boom. And in just a tiny bit more space, I have conveyed more information, right? Here I said there's a difference. Someone can say, well, what's the difference? I gotta go look at the figure. Here I can say, boom, northern was larger than southern. Okay? But what's critical is that I have the t-test there and I've reported it to, now I have my result and I have the statistics to back up my result. Okay, boom, that's a t-test. But you explain whether or not you accept or reject your null hypothesis. Okay, so I would say I reject my null hypothesis because, not a mole hypothesis, not one you're thinking over, but I reject my null hypothesis because the null hypothesis says there's no difference. And why? I would explain why. I'm going to leave that up to you. Why you think about why. Okay? And you spell everything right. Oh my goodness. Okay. Boom, 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 boom. Was there a difference in size between the two populations? Was there a difference in mass between the two populations? Here you are doing the t-test to see if there's a difference between them. Justify your answer. What does that mean? Statistics. Give me, here is the justification for my answer. I did a statistical test, right? And if the p were greater than 0.05, then I would say there was no difference between the population. Okay, there was no difference between the population. I would, in this case, accept my null hypothesis. Did I type null or did it change it? I don't know. Okay. Okay. Briefly describe how mass and length were related. Well, where are the data that you will find showing you how mass and length are related? Right? You can't look at two separate figures and say how they're related. Here's mass. Here's length. That's not going to help you. It doesn't tell you how they're related. How they're related is when you are going to plot them together. So this is a figure here that will show you how mass and length are related. It shows you the relationship between mass and length. So when you get to this question, where was I? Briefly describe how mass and length were related. You're going to look at this and you're going to say what it is. I'm not going to give you the answer to this. This is something you should be able to look at and think about. Okay? Why do you think the observed differences exist? So, biologically, what's happening? What could explain the differences between the northern and southern populations? Not northern is bigger, southern is smaller, but between the differences right here, you can see there are differences between the northern and southern population. Not just in their overall size, right? This shows you there's a difference in their size, but this shows there's a difference in the relationship between mass and length. Okay? Length is down here. Oh, sorry, southern populations is down here. Northern populations are up here. So that's a difference in size, but there's also like a difference in the way that these figures, these data are going. Okay, I'm not saying your data will look like that, but that's what we're talking about. Okay. Now, what you could do is correlation, a regression. All right, so I'm going to move this figure over here. And let's do a regression. Regression is a way to describe the relationship between X and Y data. So I'm going to import the Y range. I'm just going to do the northern Y range. And I'm going to input the X range. Actually, I want to get rid of the labels. Just do the numbers. Input the X range. I'm just selecting the X that matches the northern ones. Okay, just selecting the X that matches the northern ones. And output range, I'm going to stick it right here. Stick it right there. Hit OK. Boom. All right, so as I talked about before, what do we look for? Here is the p-value, the significance. All right, that is equal to the p of the regression. Or if you're just doing a correlation, which is really what we're doing here, of the correlation. So that p is very, very small. It's much less than 0.05. What else could we look at? Well, I'm going to show you a little trick that Excel does. Don't do this on the figures you hand in, but let's see here. Chart design, let's add trend lines. We'll add straight linear trend lines. Let's see if I can add it to north. There's a trend line for north. Let's see if I can add one for the south too as well. Excel's a little wonky about that sometimes. Okay, yeah, good. So let me add a trend line for the north, a trend line for the south. Now, here I have to do all these silly steps in Excel. I selected that trend line. I'm going to go to Format Selection, and I want it to display the equation on the chart. Click that. And now I got to come back here and try to grab this thing, and because Excel sticks it in a funky place. There. Okay. Now this is not a step that I want you to take, but I'm just illustrating to you. This right here is the equation for this line. So the slope of the equation is 2.3098, and it has an intercept of 3.8298. Where can we see those numbers? Right here. So where it says coefficients, 3.8298 and 2.30978 with rounding. This is the intercept, and the x variable 1 is also known as the slope. If we were to do the regression for the other line, the southern line, what do you think we would see? We would see that the slope would be less, right? It says a higher slope than this one. It's steeper. The northern one is steeper than the southern one. Okay, so you could do those statistics and it'll give you a different slope. That's one way maybe you could compare the two lines. And why does that happen? Well, that's up to you to interpret biologically. But the point is, I've just done this regression. I've come up with a significant value here for this regression. I have the coefficients of the regression. That tells me something about the northern data. Okay, and if I want to do the southern data, I would come to data, data analysis, regression, hit OK, and I have to change the input ranges. So I'm going to change the Y range to the southern data. I can't zoom out now, it's too late. I'm going to change the X range to the southern data, right? So I have to get these X values here. I want to change the output range because I don't want to overwrite the stuff I already have. So I'm going to put it down there. Hit OK. Boom. Alright, here's my regression. It's significant. It's not quite as tight as the other regression, but it's still very, very small value. So that is significant. And then here are my coefficients. Here's the slope. And when we look at these numbers, we have a slope of 1.145 versus a slope of 2.309. It's almost twice as much, okay? Which we can tell by looking at the figure, but now we have a number we can stick on it if you want, and that could be part of your answer. Okay, and so the last thing is differences between populations could result from crabs eating smaller snails and removing them, or from the snail population adapting over time. Consider the data in the correlation graph. What do you think the exact effect of the crabs on the snails is? So, it's possible that this difference here is not because of adaptation, it's because of the crabs eating the smaller. Let me demonstrate. Let's say we have here are the crabs. Here's the northern crabs, here's the southern crabs. Sorry, snails. That's one population. That's another population. The snails are all the same size, right? So this is length. But what would happen if the crabs came along? And so where's the average? The mean value is here for the north and here for the south. But what would happen if the snails came along and ate all of these smaller snails? Sorry, I misspoke. What would happen if the crabs came along and ate all the smaller snails? What is that going to do for the mean? There will be a higher mean because we're only looking at these snails in the northern population. Now that doesn't mean that there's any evolution occurring. Okay? It just means that the crabs have eaten the smaller snails, so that the population average has changed. But the next generation, they can make all small snails again, and the crabs come along and eat them. So this could be happening every generation. It would be indicative of evolution if over time these snails just never started to appear. Okay? So that the population of the northern snails was larger on average than the population of the smaller snails at all times, right? So the small snails have been selected out of the population. So that's what this question is getting at, okay? So you need to look at your data and figure out if that condition is true, right? Figure out, is there support for that or not? And that's it. That's what I'm gonna give you guys. Hopefully, oh wow, this is a long video, but hopefully this is helpful. And go.